On CP1-4, we'll be calculating the sum of the exterior angles of a polygon. So to review from yesterday's lesson, yesterday we talked about the sum of the interior angles, and we found the formula 180 times n minus 2, where n stands for number of sides, and the angles within an equiangular polygon are all equivalent or congruent. So the measure of one angle can be found by taking that sum, 180 times n minus 2, and dividing it by the number of sides we have, n. Interior and exterior angles are going to form a linear pair. So recall that our interior angle is this piece, our exterior angle will be that piece. It's kind of like if we extended that side, that linear pair is what we're referring to. When we look at a number of different polygons and we add up their exterior angles, 120 plus 140 is 260, plus 100 more is 360 degrees. If we take our quadrilateral, 105 and 105 is 210, plus 40 is 250, plus another 110 is 360. And you might see a pattern already, and you can confirm by adding these all up, and again you should get 360. This is not a coincidence. These are not just well-picked examples. This works with every single polygon. So for any polygon, the sum of the measures of the exterior angles is 360 degrees. There's a link for GeoGebra here for some visual proof. That's on Schoology as well. Most problems are going to be easier if you work from the outside in. And what I mean by that is if you know one interior angle is 144 degrees, it's easier to take that and say, well, my exterior angle then is 180 minus 144, or 36, and then to find your number of sides. And you'll see that in a little bit when we do some examples. So first we want the measure of one exterior angle of a regular octagon. An octagon has 8 sides, so that means it's got 8 angles. So I'm taking 360 degrees and dividing it by 8. 360 divided by 8 is the same as 180 divided by 4, or 90 divided by 2, so I get 45 degrees. Then I'm asked, how many sides does a polygon have if each exterior angle is 36 degrees? I can use that same formula. 360 degrees divided by 36 degrees each gives me the number of sides. 360 divided by 36, and has to be 10 sides. And finally, we have an example that we actually did yesterday. So we're asked how many sides are a regular polygon, and we're told each interior angle measures 168 degrees. We could say that 168 equals 180 times n minus 2 divided by n, and then multiply and distribute and subtract and all that craziness. Or we can say 180 minus 168 gives us the exterior angle. 180 minus 160 is 20, minus 8 more is 12. And now I can take that 12 and say, well, 360 divided by 12 equals my number of sides. 36 divided by 12 is 3. Tack on the 0 to account for that ones place. So I have 30 sides. When I have something like this, it doesn't actually matter how many angles I have. Okay? Instead, I'm just going to add them all up and set them equal to 360. So I have 360 equals x plus 4 plus 56 plus x plus 10 plus x minus 6 plus x. So 360, and I've got 1, 2, 3, 4x, 4 plus 56 is 60, plus 10 is 70, minus 6 is plus 64. When I subtract 64, I'm at 296 equals 4x. Dividing by 4 is really dividing by 2 twice. 296 divided by 2 is 148. Divided by 2 again, x equals 74. Something like this you will never see on your test or on a checkpoint even, but it is good practice. So we're going to look just at this first row. If I know the number of sides, 15, I can find the sum of the interior angles pretty easily because I can take 180 times 15 minus 2. 15 minus 2 is 13 times 180 is 2340. Once I have the sum, it's really easy to take that 2340 and divide it by the number of angles I have, 15. So 2340 divided by 15, I get 156 degrees each. I know the sum of my exterior angles is 360 degrees the entire way down. So I can fill in that whole chart. And now I have a choice. To find my exterior angle, I could do 360 divided by 15, or I can do 180 minus my interior angle, 156. Either way, I'm getting 24 degrees. Moving on to that second chart then. So we're looking at that second row now. So right, this one. I know my interior angle is 120. I could set that 120 equal to 180 times n minus 2 over n and solve, but it is easier to subtract from 180 and say that each exterior angle is 60 degrees. Then I can take that 60 degrees, since my exterior angles add to 360, I can divide by 60 and get that the number of sides I have is 6. It's much easier now to take my 6 and solve for my interior angles. 6 minus 2 is 4. 4 times 180 is 720. Looking at that third row now, so looking at this blue one, if I know my interior angle, it's really easy to find my exterior angle by subtracting, or vice versa. If I know my exterior, rather, I can subtract to find my interior, so I get 172 degrees. I could also use my exterior angle. Do 360 divided by my exterior angle 8 will give me the number of sides. 360 divided by 8 is 45, so I have 45 sides. And now I could take 180 times 45 minus 2 to solve for my interior angles. I can also take one interior angle, 172, times 45. Either way, I get 7,740 degrees. When I get to my very last row, so this red row, I don't have a choice in how I start. Okay, so some of these, it's like, okay, well, you could solve this way, or you could solve that way. On this one, when I have 2,880 degrees for the sum of the interior, I have to set that equal to 180 times n minus 2. And I have to solve for n before I can find anything else. So 2,880 divided by 180 is 16. So 16 equals n minus 2 when I add 2 more on. 18 equals n. Once I know the number of sides, it's really easy to solve for my interior angle by taking the sum, 2,880, and dividing by the number of sides, 18. And I get 160 degrees apiece. To find the exterior, I can either subtract, do 180 minus 160 and get 20 degrees, or I can do 360 divided by 18. On a problem like this, I'm going to go in and trace it first so it's a little bit clearer. All right, so on a problem like this, we're going to start by looking for parallel lines and transversals. So I've got a parallel line here, and that's parallel to this one. And then this side is going to act like my transversal. So right away, this 90-degree angle is going to pop down here. They'll correspond, which means that this must also be 90 degrees. Then I've got this line parallel to that line. So again, this 90 degrees will correspond there. And if that side is 90, that means S also has to be 90. So we can fill in S almost right off the bat. I can also fill in this angle because I know it'll make a linear pair with 107. 180 minus 107 is 73 degrees. And now I've got 3 of the 4 angles in this quadrilateral. 180 or 360 minus 90 and 90, I'm left with 180 for my 73 and whatever that piece is. 180 minus 73 will be 107. I could also use my parallel lines and use this side as my transversal and get 107 as my alternate interior angle. Either way works. If we go back and look at P then, I know there's 360 degrees in a circle. I've got 55 and 135 accounted for. So I've used up 190 degrees. 360 minus 190 is the same as 360 minus 200 and then adding 10 back. Okay, so 360 minus 200 would be 160 plus 10 more is 170. So P will be 170 degrees. When I go to try to find Q, before I jump down and figure out Q, I'm going to say, well, this is 170. This blue line and this blue line were parallel. So this line is acting like a transversal. The 55 from right here will swing up and be in this little corner as well. I have 1, 2, 3, 4, 5 angles. So my pentagon will add to 540. I've used up 90 plus 170, so 260, plus 107, so 367, plus 55, so 422, 540 minus 422 is 118 left for Q. Then I have another circle right here that will add to 360. 360 minus the 118 that I know, minus the 107 that I found, leaves 135 for R. And then I've got this hexagon out here. Okay, I know that T and this other angle are the same. I know that a hexagon has 720 degrees. I've used 180 from each of the 90-degree angles added together, minus 270 from the two 135-degree angles, and I'm left with 270. 270 cut in half. T and this other angle each get 135. When I'm given this example, and I apologize for how blurry the scan is, I'm looking for this angle A and for angle B right here. I'm going to start in my equilateral triangle. Because it's equilateral, each angle gets 60. Then I've got a square. Because it's a square, each angle gets 90. And then I've got this equilateral pentagon. Each angle of an equilateral pentagon gets 108. If you didn't know that off the top of your head, take the sum, 540, divide it by 5. To figure out A then, I just need to subtract from 360. So 360 minus 60, I'm at 300, minus 90, I'm at 210, minus 108, I'm at 102 degrees for A. Following that same strategy, I'm going to actually find that angle first. So I've got 360 minus the 90 is 270, minus 108 will be 162. So now I've got this triangle where I have B in the corners, and I have 162 here. And because each side is marked with a little tick mark, I know it's isosceles. I know those sides are congruent, which means my base angles are congruent. So 180 minus 162 means I have 18 degrees left. I have two equal angles, so I can split that up, and B must equal 9.